Today, we will talk about combinations. Now, the main idea here is that we are going to use combination because combinations can help us answer the question in how many ways can we arrange a group of objects. Now, in this way, when we talk about combinations, yes, we're going to start thinking about arrangement in a group, but when it comes to combinations here, the order is not going to matter. There's two ways for us to rearrange some groups. The first one is where the order does not matter, and that's called a combination. And the second one, when the order does matter, and we will see that on the next video. So here, we're going to use something called a combination, because combinations can help us answer the question in how many ways can we arrange a group of objects when the order does not matter. But now, first, before we start talking about combinations, we need to get familiar with some notations here. Now here, we need to talk about something called a factorial. Where factorial, we're going to use the exclamation sign. We use the exclamation sign to indicate the factorial of a number. Now, factorial, you can think about it as some kind of multiplication in decreasing order. Now, what do I mean by that? Well, I think examples are better than just words. So let's hear. Now, first, they're asking us to evaluate the following. So notice that here we have 4 exclamation point. But we know that the exclamation, it means factorial. So what this means is 4 factorial. Now they're asking us to evaluate 4 factorial. So what this means is that we're going to multiply in a decreasing order. So first, we're going to start with 4. And then we're going to multiply by 1 less, by 1 less, by 1 less. And we always stop at 1. Because if we continue and go all the way to 0, then it's always going to be 0. Because it's going to be all this times 0 is 0. So when we talk about factorial, we always stop at 1. So now this means 4 factorial. 4 times minus 1 times minus 1 times minus 1 until you reach 1. And then you just find out the value of this. So we have 4 times 3, which is 12, times 2, which is 24, times 1. Well, that still equals 24. So that means that 4 factorial is equal to just 24. So now if we look at example 2, we want to find our 5 factorial, which is going to be 5 times minus 1, which is 4, minus 1, and you always stop at 1. So now let's see, what's the value of this? So 5 times 4, that's 20, 20 times 3, that's 60, 60 times 2, that's 120, 120 times 1, well, that's equals to 120. Okay, so now this is the whole idea of factorial. And also, in your calculator, you can find factorial. So let's find out. What is 4 factorial? If you want to find out what 4 factorial is on the calculator, you're going to press 4. Then you're going to go to mathematics here. And then we're going to go to probability. So let's move to the right. Now that we're in probability, notice here that option 4, it has the factorial sign. So 4 factorial is equals to 24, which is exactly what we have here. And now let's see number 5. It's a 5, mathematics, move to probability, option 4, factorial, 120. So there's 2 ways for you to do it. Either if you have a calculator, just put it in, but this is the real meaning of it. It's just you're going to multiply in a decreasing order. So now that we're okay with this notation, let's actually start finding combinations. Now here, there's 2 things that you need to know. When we talk about combination, we know that the order does not matter. We want to play some kind of a grouping. We want to rearrange some kind of a group. We're not going to pay too much attention about the order of it. There's 2 things that you need to know from this key concept. And that is what n and r is. So if we read the first sentence as the number of combinations of n items. So n in some way is the total, or your groups. No, let's just call it total. N is the total. It's what is it that you have in your groups. And now R, this is the grouping. And again, groups, I'm going to put it in parentheses because it's not really groups, but it's helpful if you think about it as some kind of a grouping. So now what this line says is that you're going to have n items and you want to make groups of r. This is what this whole line is. The number of combinations of n items of a set chosen r items at a time. So what this means is that you have n elements and you want to make groups of r. Now, when we know what n r and r is, then we can talk about the actual formula. This is what combination really is. This is a formula that we can use to find combinations. Now, this formula is going to help us. How many groups of R can we make out of n total amount of elements? Now, this might seem a little bit confusing, but with some examples, you will see that it's a little bit straightforward. It's just a formula. And as long as we know n and as long as we know r, then we're okay. So remember, here we have a formula. All we need to know is what n and what r is. So let's look at the following examples. Now here is asking us find the correct answer for the following scenarios. Okay, good. So let's analyze the scenario here. As an example application, now suppose there are 6 kinds of toppings that one can choose from a pizza. Now, how many combinations of exactly 3 toppings could be ordered? So now, let's see. Do we know how many we can choose from? And do we know what kind of a grouping do we want? Well, let's see. Again, when we talk about combinations, all you need to know is n and r. Once you know n, once you know r, then we're okay. Now, n is the total. So if we read the example here, it says that suppose that there are 6 kinds of toppings. So that means that the n is equal to 6 because there are 6 toppings which we can choose from. So that's the total in your group. Now, what kind of groups do we want to make? Well, it says here, how many combinations of exactly 3 toppings could be ordered? So that means that we want to make groups of 3 because you want to find out how many combinations of exactly 3 toppings could be ordered. So you want to make groups of 3. Now that we know n, now that we know r, we have a formula right here. So what do? We just plug it in. That's all. So it's n lowercase, which in this case is 6. So we'll find that 6 combination little r, which is 3. This is equal to, let's see, n factorial, which is going to be 6 factorial. Again, all we're doing, we just plug it into the formula. Then r factorial, but we know that r is 3. So we got 3 factorial, parenthesis, n minus r, so that's 6 minus 3 factorial. Now let's see, let's try to see if we can simplify this. The 6 remains 6. 3 remains 3, so that's 3 factorial, times 6 minus 3, so that's another 3 factorial. All right, so now that we have our formula, we can plug it into our calculator and get our answer. So that's 6, and again, factorials in mathematics, probability, option 4. 6 factorial divided by, because I have more than 1 factorial on the denominator, I want to put it in parentheses. So open up parentheses, and I'm going to put 3 factorial times 3 factorial. Now that we have exactly what we want, we press enter, and that means that they're 20. So that means that if you got 6 toppings and you want to make groups of 3, there are 20 ways which you can make groups out of. Now, another way to do it is actually use the calculator. So we can use combinations straight in the calculator. How? Well, first, we can put this in our calculator, just the initial symbol, and the calculator can find our answer for us. You don't have to do this whole computation formula thing. So now, how do we do that? Well, you can put 6, which is the number on the left. So 6. Then we're going to hit mathematics. And we're still going to go to probability. And now we're going to go here where it says option 3, NCR, which is exactly what we have here. So we go down to option 3. And now we got to put the number on the right, which in this case is the 3. And we get our answer, 20. So there's two ways for you to do it. Um, I always like to start with the formula so you know where it's coming from. But it's okay if you just go from the example here, from the expression, the notation, straight to the answer. Now, let's see. If we look at example 2, it says, in how many combinations of playlists can we make with 10 songs when there are 5 songs in each and the order does not matter? Okay, so here it's telling you explicitly the order does not matter. It seems that we're making groups, so that's a hint that we want to use combination. And if we want to use combination, we need to know two things. As long as you know n, and as long as you know r, you're pretty much done. So let's see, what n? What's the total amount of elements which you can choose from? Well, it says here, how many combinations of playlists can we make with 10 songs? So we know that in total there are 10 songs, so that means that the n has a value of 10 when there are 5 songs in each. So that means that we want to make groups of 5. We know n, we know r, we know it's a combination, so we know that I have 10 combination 5. Here, you can use the formula like on your own, but let's just use the calculator to find what this is. So we can do 10, go to mathematics, go to probability, and go to option 3, which is combination. Put the right number, which is 5. So that means that we have 252 ways to make the playlist in the problem. So now, here's your entrance ticket. Try to find the correct answer for the following scenario.